Namaste and welcome back to our podcast series on science behind the science with Dr. Monica Prabhakar. We are pleased to have her back with us. Welcome back, Monica.
Namaste to everybody, all our viewers. I am so grateful to be here again with Nidhi and continuing our talk on mathematics.
So, mathematics, Ganit Shastra is what we had started, and we were speaking about the great mathematicians of Bharat and how they have brought in huge contributions, which has actually revolutionized the understanding of mathematics across the world. So, we are here back again to take this discussion forward, take this understanding forward, and bring out more from what sits in our Vedic knowledge.
Yes, Nidhi, in our earlier conversations, we have been talking about the great mathematicians. And starting from the 6th century onwards, Aryabhat, then the 16th century, Madhava, then the 20th century, we had Ramanujan. So now today our main emphasis is going to be how all these great mathematicians have contributed to modern maths. What we are learning in high school, plus one, plus two, how all these concepts they have actually originated from their works, from Aryabhatia, from the Kerala School of Mathematics, and from the formulae given by Ramanujan. In this context, let us talk about the first mathematical concept that has been a turning point in the field of mathematics. And that has been the Hindu number system. The Hindu number system was given by the great Aryabhat in the 6th century. So what actually Hindu number system is that when the number is expressed in terms of power of 10 or the decimal system, or when we actually give more emphasis to the place value of a number. So all this, the decimal system or the power of 10 makes the calculations, the micro and the macro calculations very, very simple. If we have to add, suppose 60,000 and 60,000 or multiply 60,000 and into 10,000, so the number would be great. If we split it into 6 into 10 raised to power 3 plus 10 into 10 raised to power 3, we will be dealing with the positional value and the absolute value separately. So this basically makes the whole calculation, the various mathematical operations very, very easy. So this is what was given by Aryabhat. And this concept was such a revolution that it changed the whole system of calculations. And because of its importance, it was highly recognized by the Indians as well as the people from the West. So when we are talking about 6th century, there were people who were coming to our great universities for learning. There was a lot of exchange of knowledge especially between Persia, Greece, and India. So we can how this Hindu number system traveled west. So we had in those times there were Christian monks who were coming to India for the propagation of their religion and also for learning process. Among them we have Severus Subokht. He was a Christian monk who came to India to spread Christianity, and he was a great mathematician. And what he learned here was the Hindu number system. And greatly impressed by it, he took this system to the West, that is Syria. Then we have Al-Khwarizmi. He was in the 8th century, he took the Hindu number system to Persia. Then we have Leonardo Pisano, who took this number system to Italy. And till the 12th century, it was absolutely adopted by the whole of the Western countries because of its great importance. So you can just imagine, you can just see how difficult mathematics was if we just deal with Roman numbers. It's going to be very difficult. But when you are here, the things have become so easy that you're just dealing with when you add or subtract or do any kind of mathematical operation in the decimal system or powers of 10, things become very, very easy. Basically, Aryabhatia has taken this concept again from Surya Siddhant because the calculations, such mega and micro calculations, obviously deals with the study of the cosmos. So this was the Hindu number system that was given to the whole world by Aryabhat. And for this revolutionary concept that he put forward, he was, actually called the god of mathematics, and he got the title Al-Arjbahar, and that we have talked about earlier.
Yeah, we have.
And so see the Indian mindset. Now today, if we talk about mathematics and a Vedic contribution to mathematics, I think 99% of the people would also not know Aryabhat And out of that 1%, I think many, 99 again, would say that he just gave the concept of zero. And basically what he has given is how to use that zero in a better way. That is the Hindu number system. So this is the main contribution of Aryabhat, which has changed the system of calculations.
What an amazing, I mean, I remember when we were in school, you're right in saying that when we were in school, we just had one picture of Aryabhat, and the person who introduced zero to the world is all that we've studied. So that
GK,
is
and that also in GK.
not maths, yeah.
Not maths. Not maths.
I feel also that so much has been lying under the archives, in the archives, gathering dust all this while. It's sad that we don't know about this, and I'm very glad that the kind of deep dive that you are doing into this subject, especially with respect to science, and bringing out all these nuggets and all these gems for us. It's commendable, truly.
See, Nidhi, actually, the whole idea is that I'm really passionate that this knowledge should be known to the youth of India so that they should take pride in our own system. That is just the idea that I have in my mind because that makes me work even more, telling them facts. And the more important is that our youth know it should be told facts. That is why I have quoted that this is given in the Gitika Pada of Aryabhatiya. The next concept that is very, very Indian, it is completely Indian, and that is geometry. Applied geometry actually belongs to India. And this is also followed today. And most of us don't know that we are following applied geometry that was prevalent in the Vedic times. Till today, the temples that are built today also, they are following the principles given in the our Vedic texts. So what basically is this applied geometry? The roots of applied geometry you will get in Yajurveda. Even from Rig Veda also you'll get certain concepts, but basically it is from Yajurveda where the Agni Gyan, it has been given to Nachiketa by Lord Yamraj himself, the Lord of Dharma. This is a huge knowledge system in which we have how different types of yagyas are going to be performed. And for performing these yagyas were very, very scientific. And when we performed the yagyas, there were yagyavedis. The shapes of these yagyavedis had to be very specific for complete alignment of energy. So this Agni Gyan, this whole knowledge system was called Nachiketa Agni. So it was all about the yagya system and the kind of yagyavedis that had to be formed. And this evolved later on during the Vedic times into texts which were called Sulbha Sutras. The Sulbha Sutra, Sulbha means rope. Sutra means phrases. So they were using only ropes and nails to measure and then make different types of architectural things. So the Agni Gyan got evolved into what was given in Sulbha Sutras. In that you will find quotes in which they have mentioned the different types of these Vedis. So you can have Vedis, the shape was in the form of the bird. It's called the Shyana Agni Vedi. Then we have in the form of a Rath Chakra. Then we have in the form of a Kurma, the tortoise. So these were different shapes of the Agni Vedas. So in order to form these Agni Vedis, geometry was applied. And then we have another important feature is that specifically there were three types of Agni Vedis to perform a ritual. In the Sulbha Sutras, we have three shapes that have been specified for the Agni Vedis. These are the Aha Agni, the square shape, the Dakshin Agni, that is a semicircular shape, and the Gravat Agni, that is the circular shape. So we have three shapes of the Vedis, and there was one condition that had to be followed for the construction of these Vedis, that is, they have to be of the same area.
So the circle, the semicircle, and the square, when they were made separately, had to be of the same area.
Same area. Same area. These Agni Vedis were formed simultaneously, means in one yagya.
Okay, three were required to
Vedis were
perform that
formed.
particular
Three Vedis were required, and they had to be of the absolute same area.
Interesting.
So now their geometry comes in. How to transform a circle into a square into a semicircle of the same area. So in Sulbha Sutras, you will find algorithms which mention how all these geometric transformations can take place. When you have to make these Vedis, there is one theorem that comes here, which has been quoted there.
Yeah.
That is the What will you call it today is the Pythagoras theorem. Pythagoras theorem, the Pythagoras theorem, as which has been quoted in the Sulba Sutras, basically is the Bhuj Koti Karni Nyayam. Bhuj is the base, Koti is the height, and Karni is the hypotenuse. Bhuj Koti Karni Nyayam, finding its roots in the Sulba Sutras, which go back to the Vedas. And what we call it today is the key point is that we are calling this basic theorem that has been given in our own text as the Pythagoras theorem. We are learning it by the name Pythagoras, and he is actually not the inventor.
As though it has come to us
In the name of Pythagoras. And even I was looking for some Hindi texts. In those Hindi texts also, it is Pythagoras. It is not Bhujakoti Karni Nyayam. So when these Indian concepts have been given Greek names, so that makes it sure that it is coming from not from India. So that is the main irony of the situation. We have another concept, which is very Indian in a Greek name, but so that is the value of pi. If you ask anybody, what is pi? It is just 3.142. But what actually it is, nobody would know what actually pi is. So I would like to tell you here, basically, pi is a ratio. It is a ratio of the circumference of a circle to the diameter. So circumference divided by diameter is basically 3.142.
So it's
That
3
is what
times.
we know. That is what we know. That is what we have learned. And this is pi is equal to 3.142 used everywhere in the field of mathematics. But from where has this value of pi come? This again goes back to the Rig Veda. Rig Veda talks about rituals. It talks about yagyas. If it talks about yagyas, it talks about yagyavedis. Build these yagyavedis of the same area. Square area of a square is simple. But when they were trying to measure the area of a circle, it has been quoted that this is a quote from Rig Veda. What it means is that when a rope, they were using ropes for all kind of measurements.
Correct.
When a rope stretched across the circle, a rope which is stretched across the circle, it goes 3 times around the circumference. Basically, what they are trying to say is that the circumference is 3 times
the diameter.
So the ratio of circumference to diameter is 3. So this value 3 quoted in Rig Veda is the earliest idea of pi. So there has been evolution, there has been more research that has been taken up in our Vedic times. After the basic value of 3 that was quoted in Rig Veda, Aryabhat has given his own value of pi. Now, they were not calling it pi. They were just mentioning that this is the ratio. It is just a ratio. Word pi was not used there. Aryabhat, in his Aryabhatya, there is a Sanskrit shloka, which actually means that the ratio of the circumference to the diameter is approximately, underline the word approximately. He is saying that it is approximately 3.142. So he has used this word approximately. That means he is aware that it is an endless value. After Aryabhat gave the value of approximate value of the ratio as 3.142, later on it was more evolved in the Madhava school of Kerala. He has said that 4 multiplied by an alternating series of 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus 1 by 9. So he's using an alternating series for the calculation of pi. And what he has come up is that the value of pi is actually infinite. So you can take up any number of decimal numbers as per your requirement. How many decimals, up to what decimal number you want, he has given up that you can calculate up to your according to your own needs, the value of pi. This has come up from Madhva School of Mathematics. This is what we mentioned last time, that the infinite series was one of the main contribution of Madhva School of Mathematics.
That's right. Yes.
After that, one more contribution to this value came up from Ramanujan, Srinivas Ramanujan. And what he has given is that he has given a formula for the fastest calculation of this value. Fastest calculation of this ratio. It is a very complex formula. And again, the very ironical situation here is that he himself did not know how he has calculated this formula,
Yeah.
because his work is a portion,
Revealed work. Correct.
revealed work.
Mm.
So he has, and this has been established that this formula is the fastest calculation of this ratio. I will still call it ratio before I actually mention how it traveled best. Till the 16th century, they were aware of this value, this ratio, circumference to diameter ratio, and it was an infinite number. How we get this word pi? Pi is basically a Greek letter. Pi is a Greek letter, and it is the first letter of Greek words like periphery, perimeter. Mr. William Jones, he was from Wales. So see, so the whole knowledge system was basically during the British rule, it was traveling to England. 30 years later, after William Jones used it as pi, this was established as a standard symbol of the ratio, which all the whole world is using. The Greek letter pi has been given to this ratio, and the value of this ratio has come up from India, starting from the Rig Veda to Aryabhat's work from Aryabhatiya. Then it has been more refined by Madhava,
Yeah.
and then the complex formula given by Ramanuj. So you can see see how this value has come up actually in India, but we are using now. Everybody knows that it is just pi, and because it is pi, it is Greek. When a symbol has a Greek name, nobody will even think that it has come up from India, unless and until we are living in the present time when we are talking about all this.
True that. It seems as a very vast kind of work that was happening within the framework of mathematics.
If we can talk about geometry. So this is all
Mhm.
about geometry. If you visualize any kind of temple in India, the step wells in India, you do not find such similar things in the Western countries.
Very,
So
very complex structure.
yes, so such complex geometry was very prevalent in India. You can see when the light is following in the Garbhagriha at a particular time period of the year, or it is
Yes.
following at different places in the 12 months of the year. You have such constructions, and our texts, the Sulbha Sutras. The Sulbha Sutras are basically the part of the Agamas. Agamas are the texts that talk about temple architecture, that talk about geometry. And the main text here is the Bodhyana Sulbha Sutra, that is mainly followed. The basic geometrical concepts are coming from these texts. Another concept that I would like to talk, when we are talking about geometry, we have to talk about the Shri Yantra.
Oh, that dates back even further. I mean, so it's all the way
Yes,
from the
Shri Yantra again finds its origin in Rig Veda.
Rigved. Yes.
Shri Yantra is a complex geometrical figure.
Yes.
Shri Yantra. Basically, it consists of 9 triangles, and these triangles have a common central point. And they form, when these triangles, they are constructed in such a way that they intersect at common points, and they finally form a 14 angled polygon. We have 9 main triangles forming a 14 angled polygon, and there is a common center. From symbolic concept, the symbolic meaning of the Shri Yantra basically is that the center point is the origin of the cosmos. It appears to be very simple, but when you come to its constructions, it is very, very complex. This is the 2-dimensional view. When you project it in 3 dimensions, it either in 3 dimension, it will form a pyramid,
Right.
or it will form a sphere. So it is that pyramid that is formed, it symbolizes the Meru Parvat. So if anybody is interested in the mathematical details or the geometrical details of this complex Shri Yantra, you can look up this paper. It is in the Indian Journal of History of Science, published in 1984 by the faculty of the Moscow University, Russia.
Oh.
You look up this paper and you'll find the kind of detailed geometry that is required to form this Shri Yantra in 2 dimensions. And then you have to go to 3 dimensions. So it is very, very complex. It symbolizes the center of the cosmos, which is basically Shiv Shakti, and from where the cosmos is being originating. It goes in all 10 directions. This another point that I want to highlight here is that this Shri Yantra basically belongs to Kashmir Shaivism. It was very, very prevalent in Buddhist in scriptures also, and mainly in Kashmir Shaivism. And see, when I was searching all this, I was like just wondering that Without knowledge, we are even debating on the fact that whether Kashmir belongs to the land of Bharat or not. And something as old as a Shri Yantra, it has originated in this part of Bharat. And Kashmir Shaivism is one very important part of Sanatan culture. When you talk about Shri Yantra, when you talk about the temple construction, when you talk about the construction of the Yajnavedis, everywhere it is very complex applied geometry.
Are the
So
temples, do they also have a specific style of geometry, the temples that they have to follow, just like you were talking about Yajnavedis?
we have this Manasara book of architecture, which actually details out the different styles of temple constructions that we can have. And there were rules that had to be followed.
Mm-hmm.
Is a kind of temple that had to be built. And they were very strict about the dimensions and the type of shapes. And all this is actually cannot be done without the detailed knowledge of geometry, actually.
Undoubtedly.
So you can say that applied geometry actually has its origin in India. It is not known to this depth anywhere else in the world.
Very
For
true.
sure. Yes.
Very true. And I think the world has also started acknowledging from all the latest research and the videos which are being made about these step wells and these and the temples. It's actually becoming more and more um, in the open and in a factual kind of a way that this did originate from the land of Bharat. So now from the refined value of pi and of course for the fact that geometry has been widely used undoubtedly in all the architecture that we see around, what more in the framework of mathematics do we get to understand from the Vedic perspective?
See, we have another very important concept. The name is not Indian. That is a sine function. So we have trigonometry here.
Trigonometry.
Trigonometry has been greatly detailed out again by Aryabhat.
Hmm.
Aryabhatiya is the main book, and then a lot of research has been going on in the Madhava School of Mathematics on trigonometry.
Hmm.
We can say that without trigonometry, Jyotish Shastra was not possible, astronomy was not possible. So we were way ahead in these two fields, Jyotish Shastra, astronomy. And without trigonometry, it was not possible. So Aryabhat, in his Aryabhatiya, he has mentioned about the R sine function. The important fact is that the word sine, basically sine value, it is a wave function.
Yes.
Value of a wave.
Wave.
So the value ranging from -1 to 1. So the R sine function, it has been given in the 12th shloka of Gitika Pada, Aryabhatiya.
Aryabhatiya.
Let me emphasize on this name, sine. It was originally called Jia in Sanskrit, Jia, Jia in Sanskrit. Jia in Sanskrit means a bow, something that is bent, like a bow, which also represents half wave, because it is wave function. So it is going to
Right.
represent half wave. Therefore, it is called Jia in Sanskrit. The original Sanskrit name of sine function is Jia. It was translated by Persian scholar Al-Khwarizmi, and he gave it the name Jiba. The knowledge was going westwards, exchange of knowledge. Jiba, it was called by the Persians. And the European mathematicians called it cinnamon. It means a fold or a bent, which later on got transformed in English into sine. The short form of cinnamon was sine. And what we are learning it is sine. The original form is Jia.
Jia.
Nobody would know that it is coming from Aryabhatiya.
Quite naturally.
Because
When you were talking about the fine calculations that he was doing in terms of finding the ratio between the diameter and the circumference, it did come to my mind that trigonometry would have been an integral part of also those calculations. Uh, as a result of understanding the circles and the spheres better, he would have anyway gone in that direction. So yeah, now that
yes,
you say it, of course,
yes,
it has
yes,
come from him only. Correct.
yes, yes.
Very
And
nice.
again, another one more important thing that has come is let us also discuss calculus. Calculus is differentiation integration.
Integration.
Mr. Charles M. Wish, whose paper we were discussing in our last conversation, he has completely emphasized in his paper that the work on calculus was completely known to Indians. and it was not known to any other in any other part of the world. So differentiation integration originated in the Kerala school of mathematics. Astronomy was known since the Rigvedic time. And if we have to calculate such the kind of angles, and any kind of astronomical calculation cannot be done without trigonometry, cannot be done without calculus, cannot be done without geometry. So we cannot say that its origin was here in the 16th century, but they obviously did a lot of research work in this field. So differentiation is when we are talking about everything in the micro level. And when we have to study that specific micro function in a macro level, we integrate it. So our scriptures, our Vedas absolutely talk about the micro and the macro levels. The Indians knew about the micro and the macro since the Rigvedic times.
I think the whole
So
Vedantic philosophy is in itself is micro and macro.
yes, from micro to macro and then back to micro.
Back to
From
micro.
micro, it becomes macro, and then you have to go back to the micro. And if you want to actually go to the mathematical details of it, you can just go to the main texts from the Madhava, the great mathematician, and his students. So you'll find all the formulae that you have been using today in calculus, differentiation, integration, you'll find those texts. We can actually say with great certainty that mathematics prevailed in India. The world learned mathematics from India. The most important takeaway from this conversation, Nidhi, I would think, is the chronology of events. If we just look a little deeper, what we find is that all the mathematical concepts that have come from West, they have come post 16th century, 16th century onwards, 1700, 1800, all the mathematical concepts. So these mathematical concepts were actually known to Indians. They originated in India from the 6th to the 15th century. That is from the period of Aryabhat to the period of Madhava school of Kerala.
As in that they were already present, and the Indians of that time were able to filter these out as concepts to study further. They
Yes,
were already,
and these concepts were traveling west, and they came back to India in Greek names. For example, I'll give you just a few examples. The Lebanese series, the Tycho Brahe series. Now these are Western names. These concepts have come from Madhava school of Kerala. Newton and the Gauss interpolation formulae. This is the work of Govind Swami from 8th century. And it has come up in Newton's name in the 16th century. The Hullier's formula of cyclic quadrilaterals. This is the work of Parameshwara from the Kerala school of mathematics. And it has come up with the Hullier's formula in the after the 16th century. In short, what we can say is the Indian concepts were learned by the West, and they came back to us in Western names, and completely believing that the origin of mathematics is West, but basically it is Indian. This is what our youth needs to know today.
Understood. I'm sure the relevant people who need to hear this are hearing this, and also making a note of it, because when something is such a big passion with somebody, her only intent is to deep dive and bring it out, so that it just doesn't remain in the folds of history anymore, and it begins to see the light of day just the way it is intended to. Maybe the time has come. Maybe the time was there for it to get lost. And I think when something get lost, we begin to understand its value even more. So this is the time for us to actually understand that we belong to a particular heritage and culture where it's a matter of pride to know them, to know all these things, not just with a sense of arrogance or anything, but to take pride in the fact that we are from that line that brought this out from the Vedic realm, and already was present in this country far before everything was Stone Age-ish in the rest of the world, let's say.
One point I want to make here is that in India, science and religion. They go hand in hand.
Yes.
If we are talking about temples, we are talking about science. If we are talking about mathematics, we are talking about temples, we are talking about Yajnavedis. This is what the youth needs to know today. Indian Hindu religion is not myth. It is science. If we are talking about any religious ritual also, there will be science behind it. So my whole idea here is to emphasize this point, that first believe that the whole of Sanatan Dharma is basically a scientific way of life, a scientific understanding of life. And the second thing is that if you understand it and if you are fully convinced, then be very, very proud of your own Sanatan Dharma.
Beautiful. Beautiful. What a point to end it. And when you say science and religion go hand in hand, is also because all our sages were all scientists, basically. They may have been wearing clothes which look like the clothes of people who are roaming the world, or people who've given up on life, or what should I say? How should I say?
Brahman, according to the Varna system, Brahman was a person who was a learned person.
Well, learned person.
He was a person who had access to knowledge. He was a person who understood knowledge. So Brahman was, so basically knowledge was confined to that Varna.
So you should not get confused that people who are wearing that type of clothes do not understand science.
The people who understood science were called Brahmins.
You built up so much of curiosity inside me, Monica, with all these insightful details from about our mathematicians and how mathematics evolved. I wonder what you have up your sleeve next, and what is it that we're going to be talking about in our next discussion. Maybe we can create an element of curiosity in people and tell them what we're going to come up with next.
Again, my passion, astrology.
Yes.
From mathematics comes astrology. From mathematics comes astronomy.
Brilliant.
And that is another topic that I am studying more every day, and I'm understanding it more.
Brilliant.
And I want people to know
Brilliant.
what our Indian system of astrology is.
Amazing. And I'm sure if you've been watching our series, there is a certain element of interest that has gotten picked up. Either you already knew about the subject and you wanted to know more, or you did not know about it and therefore you've gotten to know it. Either ways, you are here with us. I would definitely encourage you to share it up further with people who you think are going to benefit from this knowledge, and who you think would find it very effective to understand where we are all from. So on that note, thank you once again to you, Monica, for aiding us, helping us walk this path with you. And it's a beautiful journey that we are doing together. And there are some people who are watching it very regularly. So thank you everybody for being with us in this space, and see you again in the next podcast, where we begin the series on astrology and astronomy. Thank you very much.
Thank you so much. Thank you everybody. Thank you for listening to us and being with us in this journey.
Thank you very much.